take feedback from the sensors and give the PWMs and give the output through the inverter and motor will now. Inverter motor both are like depending on one another. Without inverter, it has a dual core and the master core is 90 Mbps and the scale is 100 Mbps. High performance and with digital signal control. This one is a DSP characteristics. Like this one we are developing micro means micro characteristics. This is nano thing. It can easily take in one box by reducing the size. So this is a micro characteristics. The main master characteristics. Here we have the serial connectors and just for controlling the PWM and I would and this is the programming issue. In Nano, we have separate the programming section. Only control section only here. Nano, just we need to reduce the size. That's why we separate the programming section. Micro, the programming is also available in and we have the total number of PWM and ADC and capture in BLDC and PMC motor we are driving drive stapler. That time we need to receive the signal from the motor. That time the capture signals we are using. And based upon the capture signals, the PWM will be out. The coding the characteristic is data controller is MATLAB communicated controller. This is the Nano 33CH. Here we have reduced the size because of compact in size. Here the all PWM section. Here the enlarged board. Here we are connected FRC connector PWM and ADC. Here we are having the RNC connector to reduce the size. Two boards are same board, but reducing the size we are separate the programming section and other section we are reduced. And here we are taking the PWMs by connecting wires here. The controller generating PWM comes here and capture signal we can connect through these connectors, phonics connector, and
Here the capture will be communicated with the controller, and this controller required 5 volt supply. We are giving the 5 volt supply through the adapter, 5 volt adapter, and here we are using the 16:2 display for display the parameters. And the DSPIC 33CH microcontroller core frequency. There are two, master and slave. Master have 18 megahertz and slave have 200 megahertz. This is the main processor. This processor we are buying from chip, microchip, and we are developing our own board. Only chip processor only we are buying and developing our board. In market, they are developing own board. In DSP, we are developing a own board. That one is in red color in compact inches. This one is a circuit, and the tracks are all are made by us. For our purpose, we are designing our controller. Master program flash memory 256 to 512 kilobytes. Slave 72 kilobytes of programming RAM. Master 32 to 48K data RAM. Slave 16K data RAM. This is the processor. DSP processor. It has 80 pins. These pins are developed by the DSP manufacturer company. We are developing only. We are buy the chip and developing it for our purpose. PWM section up to 12 PWM we can generate. In inverters, we are using 6 IGBTs. That time we can use only 6 PWMs. Whatever in buck control, boost control converters, that time we can use 1 or 2 PWMs. Based upon the application, we can use the up to maximum 12 PWM is available. We can use up to maximum 4 channel of master and 8 channel of slave. 12 PWMs have separated by master and slave. And operating mode is PWM section. Independent edge mode, variable phase PWM mode, center alignment mode, dual core, dual edge center alignment mode. And clock management. Internal oscillator, programmable PLL means phase lock loop, and oscillator clock source. The primary oscillator and internal FRC oscillator source can optionally use an chip PLL to obtain higher operating speed. PLL input frequency must be in the range of 8 MHz to 64 MHz. The PFT phase lock phase frequency detector input frequency must be in the range of 8 MHz to 16 MHz. Uh, um, we must have ADC. What about ADC? Unlike to digital converter. In this kit, the current and voltage when you run the motor in closed loop, that time the current and voltage, whatever parameter in the outside the kit, current sensor where we use voltage sensor, current sensor for reading the ROEB current waveforms and DC current, DC voltage. That waveforms can be give the ADC input, and controller can read digitally how much current it will take, how many voltage in the battery, and how much output voltage, how much output current. We can directly convert analog to digital by using the Nano 36 controller. Digital to analog conversion, DAG, by reading the one data current. For example, R phase current we are reading, that the current analog to digital, convert and read it. Whenever you see the waveforms, sine wave or square wave, it comes now, it must be displayed in digital. Whenever it's going inside is correct or not, you need to convert it up, opposite side, digital to analog. Digital signals can be converted into analog signals. One module for master core, 3 module for slave core, 12-bit DAC with hardware slope 15 numbers analog comparators. QA mode, master 1, slave 1. The QA mode consists of the following major features: four input pins, two-phase signal, and index pulse and home pulse. Programmed digital noise filter on input. Quadrature decoded, providing counter pulse and counter direction. Counter direction status, 4x count resolution. Index pulse to reset the position counter. Communication interface, three UART universal asynchronous receiver transmitter modules, two module for master core, one module for slave core, three 4-wire SPI 12S modules, two module for master core, one module for slave core, two CAN flexible data rate module for the master core, three 12C modules, module for master core, one module for slave. Applications, we are using the DSP 33CH controller, various application. Whatever application you need, maximum 12 PWMs is available. The maximum PWMs you want to apply which kind of application. In DC to DC converter means you want to one or two PWMs is enough. And AC to DC power supplies is required only minimum 4 PWMs. And motor control, PLDC, PMSM, SR, or AC induction motor required, inverter circuit required 6 PWM, minimum 6 PWMs. And space vector PWM technique like FOC and DTC we can do in 33CH controller. It is a AC induction motor run with mini IPM. This is the mini IPM power module. Here inside this one IGBT IC, CHIPAS IC, that have 6 legs in one IC. This is five. This one 230 volt input, 230 volt out. Current 10 ampere, minimum 10 ampere. 230 into 10. This is the dual core micro 28377T controller. This one is this controller. This is the main processor. This is the USB for this controller will communicate with the MATLAB. We can directly dump the program through the MATLAB. We are the blocks are generated in MATLAB. The MATLAB blocks are directly converted into hex code and dumped into the controller. And we can operate a GUI mode, graphical user interface mode in MATLAB. You can directly communicate the data between the controller and the MATLAB.
So this chip is listed in the MATLAB.
Yes, listed. We can communicate. Yes. Hardware.
This Nano is not there.
Nano is available, sir. Nano.
Is it compatible directly with?
MATLAB is available. This chip also available in MATLAB. We can directly dump the program to this controller. All controllers we are established the MATLAB based only.
Okay.
This is the programmable USB, and another one is a communication USB. For GUI mode, we need to communicate the data transfer controller to PC. That time we use the communication USB, and here we have the PWMs and captures. Here we have the 12 PWMs and 4 captures. In BLDC motor, there are 3 captures. In BLDC and sensors, QEP sensors, quadrature encoder pulse. They have the A, B index. 3 sensors. The 3 sensors input given to the capture. Capture by reading the capture signal, we are generating the PWMs based upon the. In BLDC motor, 3 phase wires are having and 3 sensor output. Normally 5 wires are coming, one ground, one 5 volt, and channel A, channel B index. That 5 volt and ground given to the given by the controller. We are giving the supply to the controller. That 5 volt directly given to the sensor, and by rotating the motor manually, the channel A, channel B index pulse are coming. Based upon the pulse, we are giving the PWM, and inverter give the output voltage to the motor. Based upon that, the continuous PWM and capture reading, by that's only the motor will be run. This one also dual core 32-bit Dell fixed point processor. Operating speed is 200 MHz. 32-bit floating point unit which support floating point operation. 1 MB 512 kilowatt of onboard flash memory with error correction detector. 204 KB of SRAM, SRAM, 16 channels, 16-bit, 12-bit at 1.1 MB per second, approximation ADC, 16 enhanced PWM, 6 enhanced captures, 32 12-bit buffer ADC DAC. This also used to any other motor application and DC to DC converters and e-vehicle and two-wheeler, three-wheeler that requires this controller. Based upon the controller PWMs, we can select the application. This is the intelligent power module. Here we are giving the three-phase input and a three-phase bridge rectifier. It converted into DC. Morning sir, Satish sir told now theoretically. It's a practically three-phase. This intelligent power module act as a, we can run DC motor and AC motor. Act as a chopper or inverter. Whatever motor we can BLDC, PMSM and SR motor, all the motor we can run with this power module. This one is a universal power module. Like here the PWM connector now, it connect to the these points by the FRC cables, and ADC is in voltage and current waveforms, VDC, IDC, I1, for the RYB current waveforms are current sensor inside the power module. The current values we can read through the ADCs by numerical value. Convert the ADC analog to digital and see in the controller display. We can see how much voltage in the DC rail, how much current taken the motor, all the parameter we can see, and also we can communicate with the GUI. The data is directly uh, come to controller, and controller communicate with the GUI. The data can be seen in graphical user interface. This one is a mini IPM. This power module. Inside this, the CHIPAS IC is this is the IGBT. Here the IGBT 6X is available now. This must be in one IC. This IC have 6 legs. This board is inside this power module. This is IPM. This is mini IPM. This is currently 50 ampere. 50 ampere is maximum current. It is 10 ampere. This is the circuit inside the CHIPAS ICs. IC number you want. CHIPAS. And later version is SPM, Smart Power Module. For now, this is CHIPAS. In older kit, we are using SPM, Smart Power Module. Now we are using the CHIPAS. This is the circuit diagram inside the. And one more things. Now the AC motor program was done by 2024 version MATLAB. Now I show the blocks.